Hello, everyone, and thank you for coming to this session. I think it'll be a good one, and it's a topic that's very near and dear to my heart. So first, to introduce myself, I'm John Whaley. I'm a founder of a company called Unifyid. We're in the behavioral authentication space. I have a long background in identity and security. Before Unifyid, I founded another enterprise security company called Mocha 5, and I got my PhD at Stanford in computer science and taught at Stanford as well. So Unifyid was recently acquired by Prove, a mobile identity company where I'm currently the SVP of emerging products. So here's the agenda for today. And I promise you, after today's session, you'll have a good understanding of the current state of behavioral authentication and where it fits in the customer journey. You'll understand some of the things that it's good for and some of the things that it's not, and how to overcome some of the challenges in deploying behavioral authentication and best practices for deploying behavioral authentication into your existing authentication flows and waterfalls. All right, sounds good? Let's begin. So a key point to keep in mind when you're designing a customer journey is that it's not just about the authentication step. You really need to have a holistic view of the entire customer journey. And identity touches every part of the customer journey. It's not just about authentication or security, and it's not just about removing friction. The brands that handle identity well will be the winners, and the smart organizations will use proficiency in identity as a competitive advantage across the board. So it's easy to get caught up in the technology, but authentication is fundamentally a human problem, and many of the challenges and opportunities come from the fact that we're dealing with real human beings with all our idiosyncrasies and complexities and foibles. And this realization has pushed authentication away from the traditional knowledge-based factors and into other forms of authentication. So the three traditional categories of authentication: something you know, something you have, and something you are. In general, the future of authentication is moving away from the something you know category, the knowledge category, for many reasons, including that we're now in the era of the data breach, and data that was considered to be private, like your mother's maiden name or social security number, is increasingly no longer private, as well as a proliferation of services that people need to interact with and authenticate with, the ease and the rise of phishing attacks, the fact that people are just not good at coming up with and remembering passwords, and the fact they're annoying, and holding on to data as a liability to your company, and a data breach in another service can lead to compromised accounts on your service. There's a growing realization that passwords are just not the way forward. And we don't see many newly developed services like being implemented today with passwords. So passwords are not going to go away completely, but they're increasingly taking a second or third seat to other techniques. So if people are moving away from knowledge-based factors, what are they moving to? Well, one is something you have, a possession factor. And increasingly, that something you have is centered around this, the phone. It could be your physical phone, your physical device. It could be your SIM card or access to your phone number. It could be access to your email. They all have their own pros and cons. And the second area that people are moving to is the something you are factors, AKA biometrics. And these are not just the traditional ones that you may think of, like fingerprint and face, although those are very important biometrics. This is extending to behavioral biometrics, something that's unique about you, about your behavior, that we can detect and use to validate your identity. It could be tied to your muscle memory. It could be tied to habit. It could be tied to your unique physiology. And one benefit of behavioral biometrics is that they can be harder to steal than your typical static biometrics like face or fingerprint. Your fingerprints, well, you leave them all over the place, and they're really hard to change. And there are databases of people's fingerprints tied to their identities. And anybody who's crossed the border recently has undoubtedly had their fingerprint registered, not to mention if you go to 24-hour fitness or any number of other services. Face is even worse. I mean, if there's nothing private about your face. Is literally what you project to the world to let people know who you are. So one company in particular used to say your face is your password. Well, your face is not your password. Your face is your username. There's nothing particularly private about your face. So what about behavioral biometrics? Can you steal those as well? Well, yes, but you actually need to catch the person doing the particular action you're interested in and be in a position to be able to capture that data. So it eliminates some class of attacks like I'm incapacitated or I'm sleeping or I'm just like not performing that operation at that time. There's also some techniques you can use to be able to guarantee the integrity of the signal to make sure it's not being replayed and it actually happened when it claimed to happen. But the most important aspect of behavioral biometrics is the fact it can run passively in the background without the user having to do anything. And because it can run continuously, you have a much wider data set to consider when you're making an authentication decision. It doesn't have to be an instantaneous measurement of what is happening right now. You can look at what was happening 30 seconds ago, a minute ago, 5 minutes ago, an hour ago, and use that to inform your authentication decision. The other benefit is because it runs silently in the background, you can run it continuously and detect changes once someone has already been authenticated. So detect changes that might indicate that an account maybe got compromised while they're in the session. So now let's take a look at some of the factors that are typically used in behavioral biometrics. So early behavioral biometrics use factors like how you type, how you navigate through a site, mouse or touch events, what IP address you connect from, when you're scrolling, do you use a scroll bar or do you use the wheel? Like these are the type of things that they use. Although these signals can be valuable from a fraud detection standpoint, they're simply not good enough for authentication. The accuracy is just too low. They have a high false positive rate. They have challenges in enrolling users as well. And then in gathering enough data to build a reliable and robust model to identify a user. And they need too much data for detection as well. So they're not really realistic to use for a login authentication use case. They provide risk signals, and the false positive rates, both the true user rejection rates as well as the attacker acceptance rates, are just far too high. So typically you may see an equal error rate of 5% or 8% or 10%, both in rejecting true users as well as letting in attackers. And 5% or 10% is not an acceptable level for an authentication solution. So this is why many of the systems that use these kind of signals are focused more on fraud detection, not on building a behavioral model to say, does this behavior look like John or not? But instead using a global behavioral model to say, does this behavior look like a bot or a human? Or does this behavior look like a fraudster or a legitimate user? Or does it look like somebody who's in a click farm or something like that? Like these are very useful for fraud detection, but not for authentication to figure out like who is the actual person. And the fundamental problem is that these signals have low complexity. They don't have enough complexity to be able to have a high enough resolution to reliably distinguish between different individuals. There's just not enough signal there. So more recently, there's a set of behavioral biometric solutions that use other factors like person's gait, for example, the way they walk, or motion sensor data, or on-device biometric sensor data. And they can also run in the background, so you can base authentication decisions even not only what's happening like right now, but what was happening in the recent past. So these type of factors are actually strong enough to use for authentication, and their accuracy is comparable to the small sensor physical fingerprint readers you typically see on phones. And therefore, you can be used to actually improve the authentication process for a user. So passwordless authentication, seamless 2FA, also authenticate across different channels. For example, when you dial into a call center or you walk into a brick and mortar store, the call center can use recent sensor data from your phone to know who is the person who's holding that device, like when that call comes in. And a door lock, it can know not only the fact that this phone is approaching the door, but if it's in the correct user's possession, the correct user is in possession of that device. And it can do that in a very highly accurate way. So I talked about motion authentication. So how does that actually work? Well, the basic idea is that you install an SDK within your mobile app that gets access to the motion sensor data on the device, even when the app is in the background. And the motion data is processed on the local device to extract these motion features, for example, a walk cycle, which is a 2-step sequence when somebody's walking, and then uses machine learning models to determine what makes that user's motion unique compared to anyone else. And the biometrics data stays on the device, but the model can be backed up to the cloud. So when a user's get into a new device, they can download the model and start using it immediately. And this becomes very powerful because when you see a new user register on a device, you really don't know whether it's the correct user or not. Just because they entered the right password, doesn't actually mean that they're correct user. But these type of behavioral biometrics like gait and motion and other type of things, they can actually give you a strong identifier that says, yes, actually this person who just set up on this new device is actually the correct user. And this allows you to authenticate the user that's in possession of the device, even in use cases where the user doesn't even have your app open, or the screen is locked and it's dark. And so that opens up a whole bunch of different use cases that otherwise you can't address. So In addition to that, like once you have an SDK that's running on the device, you can use a whole bunch of additional signals that are available on the mobile device. So device signals are one class of signals, and they provide a strong signal that is the same physical device. So you can use device fingerprinting, but all modern devices now, they include some type of hardware, secure hardware element that provides great security, and they're very difficult to hack. So you can have a private key that lives on the device in the secure element, never leaves that device, and is basically impossible to extract from the hardware. And it's used to sign everything coming from the device, so you can have very high confidence that this is the same physical device. You can also look at contextual signals, which provide a strong signal of where the device is, not just where in terms of location, because location is pretty easily spoofed, but other environmental signals as well, like what are the nearby Wi-Fi networks and routers that I see, and cell towers, and what's your network environment, and what's your IP address, and what are the nearby Bluetooth devices like wearables or beacons or Bluetooth headsets. I mean, obviously, it's technically possible to spoof any of those, but it just becomes a more sophisticated attack, and that's why you want to have a layered approach to security. And then finally, behavioral signals. Let's say what is it the correct user that's in the possession of the device, and do they have the intent to perform whatever action it is that you're trying to authenticate? And so that can include touchscreen behavior, typing behavior, swiping behavior, navigation patterns, motion data, how the device is held and operated, how the phone configuration data, habitual data, like how the device is charged, what accessories you're using, things like that. And then combining multiple of these device and context and behavioral signals together will allow you to have a very robust authentication policy that lets in good users while keeping out the bad users. And that's the whole point of authentication, is to actually let in the good users. Like most of the time it's a good user. And so like the goal of authentication should be we want to make sure we can let in the good user with the minimum amount of friction and not have them abandon the process. So the important part here is to stop thinking about authentication as a binary yes or no, and more of a dynamic decision based on multiple signals that can change over time. In fact, if you think about it, authentication was never actually a binary yes or no decision. Just because somebody happened to put in the right password, what does that say about whether it's the correct user? Well, not much. I mean, especially now, but if they put in the right password and we know that the user is at home, and we saw 30 minutes ago we saw a signal from their device, like a gate signal, and that they're walking around, and there was a 99.99% match that this is like the correct user. Well, you combine all of that information together, you can get something with much higher confidence. There's no absolutes in security. Your goal is to collect enough of these signals to get somewhere between, a preponderance of the evidence to beyond a reasonable doubt. And where you decide to draw that line is going to depend on your use case and what type of threats you want to prevent against. It's a shift in thinking, but this is the direction that authentication is going. And so once you do implement a system like this, it opens up a number of interesting use cases. So passwordless authentication is one use case, where you combine behavioral authentication with occasional push notifications or on-device biometrics to provide a seamless user experience without compromising security. You can also keep the knowledge base factor and implement behavioral biometrics as an enhancement or a replacement of 2FA, especially it gives you a chance to move away from SMS-based OTP, which is terrible for many, many reasons. You can also do cross-channel authentication, authenticate the user in different contexts, like a point of service terminal, when a payment's declined, for a call center or contact center, or like a physical access, like a door, brick and mortar store, things like that. Behavior as a strong biometric can also be used for fraud detection to detect things like duplicate accounts or promotions fraud, or those type of things as well. Let me show you a quick demo of that, just to show you how it all fits together and how it works.
Hi, I'm John Whaley, founder and CEO of Unifyid, and today I'm going to show you a demonstration of Unifyid's passive authentication technology. Unifyid makes a mobile SDK for iOS and Android that can authenticate users passively based on their motion and behavior. The accuracy is very high, and it doesn't require the user to do anything different. Just be yourself, and there's enough that's unique about you that we can actually authenticate you. You can use Unifyid's passive authentication in any case where you need security but want to have a seamless user experience, not just on the phone, but on other devices as well. Now, one of the worst authentication experiences is when you need to dial into a call center. So we've integrated Unifyid into a banking application on my phone. I've been in possession of my device this entire time. Let's see what happens when I dial into the call center.
Hello, John. Thank you for calling in from a known phone. One question, how can we help you today?
So with Unifyid, we know not only what device the call is coming from, but who is the person who's holding that device, leading to a much more streamlined user experience. Now let me put my phone down on the table and I'll intentionally not pick it up and try to dial again.
To protect the security of your account, we need to ask you some outdated questions that any hacker could answer. What is your date of birth? Could you verify the last time you made a purchase with us?
No. See, that is the typical call center experience. Now let me pick up the phone, I'm gonna walk around a few steps and try to dial again.
Hello, John. Thank you for calling in from a known phone. One question, how can we help you today?
Now, how did that work? Well, we're using two signals here, your unique gait and motion, and also detecting when the phone's put down or out of your possession. It turns out your motion is unique enough that we can actually authenticate users with the same accuracy as a physical fingerprint based purely on their unique motion. And because it runs in the background, you don't need to be walking all the time or even have the app open or the phone unlocked. We can use motion data from 5, 10, 15 minutes ago and use that to make an authentication decision. This allows you to understand much more about the context and what the user is doing and incorporate that into an adaptive authentication policy. So this is just one example of how to use Unifyid's passive authentication service to authenticate users in a much more seamless way.
So how do we put it all together? Well, here's an example of an authentication waterfall and how passive behavioral biometrics can fit in. So at the top of the waterfall, we have motion. It's actually, motion authentication is actually strong enough to authenticate the user. So if we have a positive match on the motion authentication, like for example, we saw the user walking and we have a strong match there, we can actually authenticate the user at that point. And the interesting thing about this is it goes across different devices. So even if the user is registering on a new device, if their motion print matches, we can actually say with high confidence that it is the correct user. If you don't have motion data or if you don't have a match for some reason, you can fall back to say, hey, is this a trusted device? Have I seen this device before? And you can also use things like mobile authentication, where you use SIM-based authentication to know that this is the right phone, it has the right owner, it hasn't been SIM swapped recently. Those type of things to say, hey, that I'm confident about this. And each of those are 100% passive authentication. So if you're able to succeed in any of those, then you can say, okay, I'm going to passively let the user log in because I have high confidence that this is the correct user. If it doesn't, you need to fall back to on-device biometrics or other forms of authentication like an instant link delivered via SMS or voice OTP or some other form of authentication. And so what about if you want to do some type of high risk transaction that requires some sort of step-up authentication, right? So again, you can use motion authentication. If that matches, then that that's a strong match, and you can use that, regardless of whether what device that you're on. But in the case that you don't have recent motion data, then you can do things. You can either look at a trusted, is my current device trusted, in some way, or if my current device is not trusted but the user has access to another device that is trusted, you can send some type of push-based authentication to that trusted device and say, hey, do you want to allow this to happen? For example, if somebody's doing something through a website, you can send a push notification to their phone and say, hey, somebody's trying to do this operation. Like, is this okay? Like, do you want to approve this, right? And if that's sent to a trusted device, and you combine that with something like on-device biometrics, like a Face ID or a Touch ID, then you can get something that is very
a very strong form of authentication while still having a great user experience, right? And if those fail, then you can fall back to more traditional factors, or other type of fallback factors, instant link, voice OTTP, other step up, KVA, et cetera. But it's, so this is examples of how you can fit in, these type of behavioral biometrics into Authentication Waterfall. And again, it really depends on your use case and the threat models that you're trying to prevent against, right? And again, when you look at these, the benefit of behavioral biometrics is because it's passive, because it runs in the background. There's essentially zero cost to the user. Like, they can be running in the background. And the user doesn't have to do anything, and you can check these. And so this is why typically you want to have those type of factors more higher up in your waterfall, because they're essentially zero cost. So let's talk about some of the best practices for behavioral biometrics for authentication. So first piece is that you should really look into utilizing the phone as some type of omni-channel secure authenticator. The fact is that so many people carry these things around now, and they're almost ubiquitous, and they are extremely powerful. I mean, they have a lot of sensors on them. Many times they may have like a camera for Face ID. They may have a sensor for some type of fingerprint reader. And the fact that they also have a secure element on the device that you can be very confident that have this secure channel of communication to be able to communicate with the user. And instead of having something where, okay, well, type in the 6-digit code, and then we're going to use that to authenticate, and maybe that code, it could come via a text message, like an SMS. It could come via like an app, like a time-based one-time passcode. There's a whole class of attacks that you can avoid by doing this, and it's not a great user experience either. I mean, having to type in this code. I mean, come on, it's 2021 now. We can do much better than I have the code on my screen on my phone. I need to physically type it in somewhere or copy and paste it. Like, that's just silly at this point. And and it also opens you up into a lot of attacks, these type of social engineering attacks, where somebody may trick somebody into giving up that code. And this is a very common attack now, because typically when you receive those codes, there's no context about what operation is being attempted. And so you may think you're giving the code to prove your identity or to log in or something like that, but actually somebody's using this to set up a new account, or transfer all the money out of your account, or those type of things. So this is where if you can utilize the phone as an omni-channel secure authenticator, the user, you have a screen here. The user you can see the full context under what the operation is being attempted. You can utilize all the sensors and knowledge and security that's involved in the mobile device. And so if this is an option, then this is a very strong way of doing authentication that is a great balance between security and user experience. The second best practice is to build a layered authentication strategy that combines many of these factors together. There are no silver bullets in security or authentication, despite of what salespeople may tell you. And you really need to have a layered defense in depth approach to any of these type of security or authentication factors. So, combine signals from the device, like, is this the correct device? But that's not sufficient. I mean, there's a lot of cases where, something, it may be the same device, but it may be a different person that's utilizing it, right? Contextual signals, again, kind of like not just location, but like other things around the context, the constellation of devices and signals that are around your device at any given time, and then behavioral signals. And then you want to have intelligent fallbacks there. So, don't do something like, if I'm gonna look at the user's location, and I know the person's at home, but some other signals don't match, right? And so maybe you're worried about, okay, maybe this is a spouse or a family member or something like that, who has access to the device, or like, somebody who knows where the person lives and is spoofing their GPS, right? If your fallback for that is something like, well, let me ask the user their address. Well, you didn't really gain any information, right?
I mean, like the fact that like, well, it's either the attacker already knew the address and is spoofing it, or somebody's physically at that location, in which case you're asking them for what's the user's address is not really going to give you any additional information. So you want to be really intelligent about the fallbacks that you use, especially when it comes to knowledge-based factors or other type of explicit authentication steps, and then use that to basically shore up the different types of authentication and the different types of threat models that you're trying to prevent, right? The third best practice is, if it's possible, passively capture data before the user is actually in session or before they're actually interacting with your service. Because getting knowledge like, okay, well, 30 minutes ago, we saw the motion data on this phone, and it was a 99.999% match with the person's gait and their motion, right? Like, and the fact that that happened 30 minutes ago, that is a very useful piece of information to know when you're trying to build robust authentication policies. And so, the truth is, if you're only looking at the data when somebody's actually in session or interacting with your service, you have a very limited window, and you don't really understand the context of what the user's doing. And so it makes it really difficult to build a really strong, robust authentication policy in that case. So, if it's possible, try to capture and use data from before the user's in session, because that will provide a lot more information about the context of what the user's doing and whether it's the correct user or not. The fourth one is consider how to handle user enrollment gaps or data gaps. So there's a lot of, you have to think about how you're going to actually enroll users into this, right? If you're only capturing data like when you're on a web page, for example, and you're looking at typing behavior, things like that, it requires a minimum of 12 to 15 interactions of a behavioral, with any type of behavioral system, to be able to make a model that is reliable enough to say, well, this is the user versus not, right? And so if you only capture data when somebody is actually typing on your site, and if they during the login process, then they're going to have to log in 12 or 15 times at the minimum to be able to generate a model for that user. Right? And that's depending on the use case. I mean, maybe it's something you only log in once a month or longer. That can quickly become untenable. Like, how are you going to actually enroll that user? And then also, how are you going to handle gaps in the data in real life? There are many cases where you just do not have access to some data. It could be about permissions. It could be about connectivity. It could be about just all sorts of things. And so the system needs to be able to intelligently handle these types of the result is inconclusive, or the result is I don't know, because I just don't have the data. And so you need to be able to handle this in these type of cases, in your authentication flows. Right? And then finally, the last best practice is to evaluate the performance of the system with using real production data in your environment. Don't just trust the vendor to say that, hey, we are this accurate, whatever. And because the truth is, like, especially with this type of behavioral biometrics, it varies a lot depending on the use case and the user base, right? And what the users are actually doing. And so the best way to evaluate these type of solutions is to actually roll them out in a production environment to some subset of users. Don't actually hook it up to anything in terms of making a decision, but just have it record the data. And so you can then look at that data and analyze it, after 30 days or 60 days or 90 days, run some trial period where you can actually look at the data that you get and see, is this system actually providing real value, right? And the best way to do that is to actually do this utilizing real production data in your environment. So that concludes today's presentation. As I mentioned, behavioral biometrics it's a very exciting space, and things are definitely moving in this direction. There are no silver bullets in security or authentication, but certainly behavioral biometrics has an important place in authentication flows and in authentication waterfalls. Again, my name is John Whaley. Feel free to reach out to me if I'm very passionate about all things security and authentication, and I'd love to connect with you. Thank you.